Okay, today in the the third grade, we're going to work on a word problem that's going to use addition and subtraction, and we're going to solve it using Make 10. So the first half of the word problem is about Matt and Curtis, and Matt and Curtis have baseball cards. Matt has 55 and Curtis has 38. And they want to know how many they will have if they combine their two card collections. So we want to make our two sets of numbers. So our first set is 55. So we're going to use our base 10 blocks, or the rods of 10, to represent 50. So we're going to get 5 of them. 1, 2, 3, 4, and 5. And then 55, so we have to have 5 ones. So we're going to get 1, 2, 3, 4, and 5 ones. And this is our first set. Our second set of numbers is 38. So we're going to get 3 rods, 1, 2, 3, to represent 30. And then 8 ones. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, here's where we're going to regroup to add the two sets together. We have a group of 5 right here and a group of 8 right here, and I know that 5 and 5 is 10. So I'm going to take 1, 2, 3, 4, and 5 from this pile of ones and move it over to this pile of ones so that I have a group of 10 ones. And we can regroup that by replacing it with another base 10 rod, and we take those away. Now I have 1, 2, 3, 4, 5, and 6 base 10 rods over here, which is equal to 60. So we have the number 60 over here, and then we have 1, 2, 3 over here, 30, and then 3 ones. 1, 2, 3, so 33. The next thing we're going to do is combine all of our base 10 rods, so we can count that we have 1, 2, 3, 4, 5, 6, 7, 8, and 9, which is equivalent to 90. And then we have 3 ones left over. So 3 ones plus 90 is 93. And so we know if Matt and Curtis combine their two baseball card collections that they're going to have 93 baseball cards altogether. The second part of our problem is that the boys have a friend come over and he accidentally knocks over a glass of water. And when doing that, he ruins 19 of their baseball cards. So now we have to figure out how many they have left now that 19 of their cards have been ruined. So one misconception that can happen is when using base 10 blocks as a model is that you need to set up the number 19 along with the first one, but really we're just going to be taking away from there, so we only need to work with the one model we already have. So what we're going to do first is 19, there's 9 ones in that, but we only have 3 ones in this number, 93, so we need to take one of our rods and replace it with these ones, or regroup it with these ones. So we're going to bring our 10 ones back over here, and we took this one away, and now we have 13 ones right here, and we're going to take 9 away from that, so we can just count it out. 1, 2, 3, 4, 5, 6, 7, 8, and 9, and move those away. Those are taken away, and we have these ones left over. Now, we took care of the 9 ones in 19, but we haven't taken care of the tens place, which is 1. So we need to take care of 1/10, which is equivalent to 10. And once we take that away, we have our total number left, which is 1, 2, 3, 4, 5, 6, 7 base 10 rods, which is equal to 70. And then we have 1, 2, 3, 4 ones left over, which is equal to 4. And when you put those together, we have 74. So we know now that 19 of their cards have been ruined that they have 74 baseball cards left over. Okay, today in 4th grade we're going to work on elapsed time, and we're going to do this using a linear model. We have a word problem that's going to tell us what we're doing today, and it's about Sally, and Sally's going to go on a trip, and she starts her trip at noon, at 12 o'clock p.m., and she's going, her GPS, she plugs their destination into her GPS, and it tells her that it's going to take her 2 hours and 45 minutes to get there. So she wants to know what time she's going to arrive at her destination. So like I said, we're going to use the linear model, so we're going to make a line, and we're going to label our starting point at 12 p.m., And we know that she has, the GPS told her it's going to take her 2 hours and 45 minutes to get to her destination. So the first thing we can do is take care of our hours, which it's like this is equal to this portion. So we're just changing this number. This number isn't going to be changed at all when we're just working with the hours. So the first thing we can do is make 1 hour jump to bring us to 1 o'clock. And this jump is equal to 1 hour. Now we've taken care of this hour, so we have an hour and 45 minutes left. And if we do the same exact thing, do another hour jump, and label that, we know that 12 plus 1 is 1, 1 plus 1 is 2. And these are both PM. And I should mention the reason it goes from 12 to 1 is because every time your clock hits to 12, it's going to start over again because it's in base 60 instead of base 100. So I should have mentioned that earlier. So we can see on our clock that it doesn't go 12, 13, it goes 12, 1. So we know every time that the hour gets to 12, it's going to switch over to 1. Okay, so now that we've taken care of this second hour, 1 hour, we can work that out. And now we just have our 45 minutes left. Instead of taking a big 45-minute jump, we're going to break it down into friendlier numbers. I'm going to do, since it's 4, we're going to do 4 sets of 10, so 10 4 times, and then 5. And we know 10 plus 10 plus 10 plus 10 plus equals 45. So the first jump of 10, this is working with minutes, not hours anymore, so it's going to change this number, not this number. So we're adding 10 to here, so 0 plus 10 is going to be 210. We can mark out one of our tens. And then we do another 10-minute jump. We can label that to 20 because we add 10 to 10, and that's going to get us to 20. And label up here too. And then we're going to do another 10-minute jump. We have 2 more. And we add 10 to 20, and that's going to be to 30. And then we have another 10-minute jump. And 10 plus 30 is going to be 40, so 240. And then we have just one more jump of 5 minutes. I'm just going to do a littler jump. And 5 plus 40, because we're still just paying attention to the minutes in this case, is going to be 45. So Sally knows that if her trip starts at noon and it's going to take her 2 hours and 45 minutes, 1 hour, 2 hours, and 45 minutes, that she's going to arrive at her destination at 2:45 p.m.